Hi guys, I am Teacher Joel and good morning or good day. So today we will be learning on how to find the sum of the given arithmetic sequence. So in finding the sum of the arithmetic sequence, we have two formulas to be used. The first one, if the last term in the first term is given, so we will use the formula S sub n, which is equal to n over 2 multiplied to a sub 1 plus a sub n, where our a sub 1, of course, is our first term, our n stands, or a sub n is our last term, and our n stands for the number of terms that we have. And if the last term is not given, so we will use the second formula, which is S sub n is equal to n over 2 multiplied to 2a sub 1 plus the quantity of n minus 1 multiplied by the common difference, or d. So we will have our example. First example, find the sum of the first 20 numbers. So we will look for the sum of number 1 to 20. Of course, we will write the given first. So for the given, we have first term is 1. And our a sub n, or our a sub n is equal to 20, our last term. And for the number of terms, we have 20, since it is number 1 to 20. And we will look for the sum of terms, or S sub n. So we have the solution, or since our first term and the last term is given, so we will use the first formula. So given S sub n is equal to n over 2 multiplied to a sub 1 plus a sub n. Just substitute our given to our formula. So our n, which is equal to 20, so n over 2, or 20 over 2, times the first term, which is 1, plus the last term is equal to 20. And then simplify our answer. 20 plus 1 is equal to 21. 20 over 2, or simply 20 divided by 2, is equal to 10. And if we will get the product of 21 and 10, or if we will multiply 21 and 10, it will lead us to a product of 210. Therefore, we can conclude that if we will add number 1 to 20, our answer is equal to 210. If you are not satisfied rather with our solution, you can just add 1 plus 2 plus 3 plus 4 up to 20 and check if our answer is equal to 210. Okay, for the second example. Find the sum of the first 16 terms of the arithmetic sequence 8, 11, 14, 17, 20, and so on and so forth. So we have the given. For the given, we have a sub 1, which is equal to 8. For the n, or for the number of terms, since it is stated on our given that we will find for the first 16 terms, so therefore, we have 16 terms in total. So our number of terms is equal to 16. Our d, or for the common difference, we have, or in finding the common difference, we will just subtract the second term to the first term. So 11 minus 8 is equal to 3. So that is our common difference. And we will look for the number, or yes, the number which is the 16th term. So what is the number in the 16th term? Since we do not have the last term, so we will use the second formula, which is S sub n is equal to n over 2 multiplied to 2a sub 1 plus n minus 1 multiplied to d. And just substitute that given to our formula. So our S sub n, or S sub 16, is equal to n, which is 16 over 2 multiplied to 2 times a sub 1, which is the first term, which is equal to 8, plus n, which is equal to 16 again, minus 1, times the common difference, which is 3. So we have to simplify. 16 over 2, or 16 divided by 2, is equal to 8. And then 2 times 8 is equal to 16, plus 16 minus 1 is equal to 15, right? And 15 multiplied to 3 is equal to 45. And simplify again. Just copy 8 and then add or get the sum of 16 and 45. 16 plus 45 is equal to 61. And if we will multiply 61 to 8, it will lead us to a product of 488. Therefore, the sum of the 16 terms, 8, 11, 14, 17, 20, and so on, up to the last term, which is the 16th terms, is equal to 488. And if you are not satisfied, since we have the common difference 3, just add 3 here for our last term. 20 plus 3 is equal to 23. 23 plus 3 is equal to 26. And then, until you reach the 16th terms. And if you reach the 16th terms, just add all that terms and you will get the sum of 488. Did you get it? Are you following? Can we proceed now to our third example? Okay, so we will now proceed to our third example. So for our third example, we have the problem. If the first n terms of the given sequence, 9, 12, 15, 18, and so on and so forth, are added, how many terms given a sum of 126? Don't forget to write the given. So for the given, we have the first term, which is equal to 9. For the common difference, second term, which is 12, minus the first term, which is 9. So 12 minus 9 is equal to 3. You got it right. So that is the common difference. And for our sum of terms, if we will add all the numbers, we have 126. The question is, on what terms or how many terms do we have to get the sum of 126? That is n. That is the unknown. And since only the first term is given and we do not have the last term, so we will use the second formula. So the second formula, which is S sub n is equal to n over 2 multiplied to 2a sub 1 plus n minus 1 multiplied to the common difference. So substitute again the given to our formula. So our S sub n, or the sum of the terms, is equal to 126. Our n, which is a known, over 2 multiplied to 2 times the first term, which is 9, plus n minus 1 equal, or n minus 1 times the common difference, which is 3. Simplify our answers, or answer rather. 126 is equal to n over 2. 2 times 9 is equal to 18. N minus 1 times 3, or use the distributive property. 3 times n is equal to 3n. 3 times negative 1 is equal to negative 3. And then, simplify again. 126 is equal to n over 2. 18, or combine like terms. 18 minus 3 is equal to 15. So we have 3n plus 15. And then, distribute or multiply this n over 2 to our 3n plus 15. So we have 126 is equal to 3n times n is equal to 3n squared, just copy the denominator 2, plus 15 times n is 15n, copy the denominator 2. And since that on our new expression or equation, we have the denominator 2, so to simplify, get their LCD, or the least common denominator. So for the LCD, since our term here do not have the denominator, and our two terms here on the left side has its denominator, and they have the same denominator, so that is our LCD, or the least common denominator. So that is 2. So multiply both sides by 2. It is the multiplication property of equality. Whatever you multiply on the left side, just multiply on the right side. So 126 times 2 is equal to 252. You got it right. So 3n squared over 2 multiplied to 2 is just simply cancel out 2. So the remaining term is 3n squared. Same thing on the 15n over 2. Just cancel out the denominator. So remaining term is 15n. And then equate that to 0. So 0 is equal to 3n squared plus 15n, or substitute 252 on the left side. So we have 3n squared plus 15n minus 252. Since you transpose the 252 on the left side, so the sign will change into negative. And since all our terms is divisible by 3, so we can simplify our answer. So by dividing these terms by 3, so 3n squared plus 15n minus 252 divided by 3. 3n squared divided by 3 is equal to n squared. 15n divided by 3 is equal to 5n. Negative 252 divided by 3 is equal to negative 84. And since we simplified already our answer, which is n squared plus 5n minus 84, and since it can be factored out, therefore, the factored form of n squared plus 5n minus 84 is n plus 12 and n minus 7. How to get the factor of n squared plus 5n minus 84? So simply, get the factor of 84, or get two numbers that if we are going to multiply, the answer is 84 or negative 84. And if we are going to add that two numbers, it will lead us to positive 5. So 12 times 7 or 12 times negative 7 is negative 84. And 12 minus 7 is equal to positive 5. So therefore, our factor is correct. And then, get the roots of that factors. So n plus 12 is equal to 0 or equating to 0, and transpose on the other side. Therefore, our n is equal to negative 12. N minus 7 is equal to 0. So our n is equal to positive 7. And go back to our problem. Since our arithmetic sequence are all positive, it is increasing, right? It is increasing into positive. From positive to the highest number, positive also. So therefore, we will get the positive number. Therefore, n is equal to negative 12 is not our answer. So the number of terms we have is positive 7, since our number of terms is or only positive. So therefore, our answer again is 7. Our n is equal to 7. Question before we proceed. Okay, since no question, or if you have questions, just comment down below or just PM me. Okay, for the fourth example, find the sum of the integers between 1 and 70 and are divisible by 3. So therefore, we will get all the numbers between 1 to 70 that is only divisible by 3. Since 1 and 70 is not divisible by 3, so therefore we will just omit 1 and 70. So therefore, our first term between 1 to 70 is 3. 3 is divisible by 3, right? And then, since if we are going to list down all the numbers that is divisible by 3, it is 3, 6, 9, 12, 15, and so on and so forth. So therefore, automatically, our common difference is equal to 3. 6 minus 3 is equal to 3, right? So the common difference is 3. Our a sub n, or the last term, is 69. 69 is divisible by 3, correct? Yeah, it is divisible by 3 because 69 divided by 3 is equal to 23. You got it right. And we do not have the number of terms. And we do not have the sum of the terms. So therefore, we will look for n, and we will look for the sum of terms. Since we have the given arithmetic means, or the a sub n, which is equal to 69, so to look for the value of n, we will use the arithmetic formula. So a sub n, which is equal to a sub 1 plus n minus 1 multiplied to d. Our a sub n, or the last term, is equal to 69. First term is equal to 3 plus n minus 1 times the common difference, which is 3. So distribute 3 times n is equal to 3n, and 3 times negative 1 is equal to negative 3. Combine like terms. 3 minus 3 is equal to 0, right? Okay, so we have 69 is equal to 3n. And then, just get or simplify our answer. Since we will look for n, so we will cancel out this 3. To cancel out 3, we will divide it by itself. Whatever you divide on the left side, divide that on the other side, as it's stated on the or it is stated in the division property of equality. So 69 divided by 3 is equal to 3n divided by 3. So cancel out 3. So n is equal to 23. 23 times 3 is equal to 69. So therefore, our n is equal to 23. Since we already have n, which is 23, so we can now look for the sum of the terms. So looking for the sum of the terms, we have s sub n. Since first term is given, which is 3, so we will look for s sub n, or the sum of the terms, or we will use the formula n over 2 multiplied to 2a sub 1 plus n minus 1 multiplied to d. So s sub 23, which is n, equal to 23 over 2 multiplied to 2 times 3, which is first term, plus n, which is 23 minus 1 times the common difference, which is equal to 3. 23 minus 1 is equal to 22. 22 times 3 is equal to 66. And then get the sum. 66 plus 6 is equal to 72. And multiply that 72 to 23 over 2. 72 times 23 divided by 2 is equal to 828. So if we are going to add all the terms, or if we are going to add 23 terms, it will lead us to 828. 828 is also divisible by 3, right? You can just check that on your calculator. Okay, do you have any questions? None? I have last example for you. Okay, so we have our last example, or the fifth example. The sum of the first 15 terms of an arithmetic sequence is 765. If the first term is 23, what is the common difference? Or we will look for the d, or the common difference. So given, again, the first term, which is 23. Our number of terms, since we have 15 terms in total, so we have 15 as n. Our sum of the terms is equal to 765. So we will look for the common difference. Okay. We will use the formula again. S sub n is equal to n over 2 multiplied to 2a sub 1 plus n minus 1 multiplied to d. So s sub 15, which is n, 15 over 2 times 2 multiplied to 23 plus n, which is 15 minus 1 multiplied to the common difference. We have no common difference. So s sub 15, or the sum of the terms, is 765. 15 over 2, 2 times 23, which is 46. 15 minus 1 is equal to 14, multiplied to d, which is equal to 14d. So we have to multiply 15 over 2 to 46 plus 14d. So 15 over 2 multiplied to 46 is equal to 345. Check that on your calculator if I am correct. 15 times 46 divided by 2. Same thing as to 14d multiplied to 15 over 2. 15 times 14 divided by 2 is equal to 105d. And then, so we have 765 is equal to 345 plus 105d. And then combine like terms. To combine like terms, combine all the numbers, or combine all the terms that is alike, or that are alike. 765, 345 will transpose on the other side. So 765 minus 345 equal to 105d. 765 minus 345 is equal to 420. So 420 is equal to 105d. So we will cancel out 105 by dividing by itself. So divide both sides by 105. So we have the common difference, which is equal to 4. Cancel out 105, so the remaining is d. 420 divided by 105 is equal to 4. Questions? If you have questions, You can comment down below or just message me on my Facebook account. Okay? See you on our next session, and thank you so much. Hope you learned a lot from me today. God bless. Stay safe.